Today we're going to be learning about combinatorics. Students will compute and distinguish between permutations and combinations. So we're going to start with the fundamental counting principle. If one event can occur m ways and another event can occur m2 ways, then the ways that they both can occur is by multiplying them both together. So you want to roll a die, pick a card from a standard deck, and flip a coin. How many total ways could this happen? Well, when we roll a die, there's 6 possible outcomes because there's 6 sides to a die. When we pick a card from a standard deck, there's 52 options because there's 52 cards in a deck. And when we flip a coin, there's 2 possible outcomes because there's 2 sides to a coin. If we multiply those together, we get 624. So there are 624 possible ways that 624 possibilities basically of what could happen. So the standard configuration for a Virginia license plate is 3 letters followed by 4 numbers. How many possible license plates are there in this configuration? Well, there's 26 letters in the alphabet, so 26 options for the first letter, the second letter, and the third letter. Then if we're using the digits 0 through 9, that's 10 options, 10, 10, and 10. If we multiply that out, so there's 175,760,000 possibilities for the license plate. But how many possible plates are available if the letters can't repeat? So if they can't repeat, that tells us that there's 26 options for the first letter, but whatever letter we use for the first letter, we're not allowed to use again. So then there's only 25 options and then 24 options. Now they didn't say anything about the numbers not repeating, so those will all still be 10s. So that takes us down to 156 million options. Now, what if the letters and the numbers can't be repeated? Well, then it'd be 26 times 25 times 24. Then we'd have 10 options, then 9 options, then 8 options, then 7 options. Then there'd only be 78,624,000 options. Ten students are competing in the Parkview talent show. How many different ways can all the contestants be placed, assuming there's no ties? So when we're deciding first place, there are 10 students, there are 10 options. Once first place is chosen, there's only 9 options for second. Once that's chosen, there's only 8 options for third, fourth, all the way down until we choose the last person. So there would be 3,628,800 possible ways we could arrange all 10 people from first to last place. Now, what if we just wanted to choose the students in places 1, 2, and 3? So this is called a permutation. That means the order or rank matters. So the order that we choose them in is a big deal because there's different rankings. If we choose you first, you're in first. If we choose you second, you're in second. If we choose you third, you're in third. So we're going to do this on Desmos. We're going to go to our keypad. We're going to choose functions, and we're going to go to our statistics tab. And we've got NPR down here. So go to the keypad, functions, statistics, and then the one that says NPR. The N stands for the number of things we're choosing from. So since there was 10 students in the talent show, and we're going to put them into the first 3 places. So 10P3. So we're going to go back over to Desmos. And in our parentheses, we're going to put our 2 constraints. So we're taking 10 people, comma, we're picking 3 of them. So there are 720 ways we can put them in order. So you're making a list of hikes on the Appalachian Trail for fall break. You have 10 available hikes, but you only want to go on 6 of them. How many potential different itineraries can you make? So itineraries includes the order you're doing things. So from our 10 trails, we're picking 6 of them in a certain order to go. So 10, 6. There's 150,200 options. Sorry, 151,200 options. Now, what if the order that you hike them in doesn't matter? Basically, you're saying you're just going to choose a group of 6. That means we're now dealing with a combination, not a permutation. So the way I think of it is a permutation, you're putting things in a certain order or rank. A combination, you're choosing a group. And basically, same place on Desmos. We're going to choose the keypad, functions, stats, and then it's NCR. So if we want 10, or we have 10 trails, we're going to choose 6 of them. Any 6, the order we do them doesn't matter. So functions, stats, NCR, 10, comma, 6. Now we're down to 210 possibilities. A deck of playing cards has 52 cards. How many ways are there to deal a 5-card hand? So when you're looking at your hand, in most games that you're playing with a deck of cards, the order that you get them in your hand doesn't matter. So we've got 52 cards. We're going to choose 5 of them. So NCR, 52. We want 5 of them. There are 2,598,960 options. Now, what if we want them all to be the same color? Well, there's 26 red cards and 26 black cards. So that narrows down our pool of cards to 26. We're still choosing 5 of them. Instead of 52 cards, we're going to start with 26. And now we're down to 65,780. Yeah. That's all for today. Fill in your summary, and I'll see you in class.